Hello, my dear students. So you now see the thumbnails oxidation state. आज हम ऑक्सीडेशन स्टेट के बारे में स्टडी करेंगे. So about me, I am Subhash sir. So without the late, next topics start. First, oxidation number. Oxidation number. What is oxidation number? A numerical value representing the electron gain or losses during the chemical bond. Means that in the chemical bond, formation of the time gain or loss the electron in the chemical reactions. Example, Na release the electron, then the formation of Na plus release electron. They are oxidized into the positive, and negative reduced Cl release accept the electron, and get into the reduced. Next, zero oxidation means that any covalent bonded molecules have the zero oxidation state. Range about the range -4 to +7. In the P tables, any substance have the minimum oxidation number -4 and maximum oxidation +7. These are defined the subscript form Fe3 plus or Roman number third or parenthesis form the +3. These are three types defined oxidation number and indicate the chemical reaction in the chemical activity. Means that oxidation number release the electron positive, gain the electron negative, and no gaining or no releasing the electron have the zero oxidation state. Next, range of the oxidation number. Here the list about the common oxidation number. Metal and non-metal in the P tables have the different types of element. First, alkali metal. Alkali metal first group have the +1 oxidation. These are short form learning or listening chemical reaction. Alkali metal have the +1. Alkaline earth metal have the +2. Alkali metal example lithium, sodium, potassium. These are have the +1 oxidation state. And alkaline earth metal beryllium, magnesium, calcium. These are the +2 oxidation state. And the transition element in the D block have the different types elements. First D block series, 3D series, zinc to scandium to zinc, +2 +4 oxidation state. Copper have the +1 +2, silver +1, gold +1 and +3. Two types of oxidation state. The lanthanide series +2 +7, lanthanide and actinide series. In the P block elements, carbon -2 +4, hydrogen exception है +1 0 -1, nitrogen -3 +1, oxygen -2 +2, fluorine -1, chlorine -2 +7, and bromine -1 to +7, and last element iodine -1 to +7. Means that these are in the range different types of oxidation source. -1 0 +1 half the hydrogen. Carbon -4 to +4, -4 -3 -2 -0 -1 1 2 3 4. Nitrogen -3 -2 -1 0 +1 +2 +3 +4 and +5 in the different compounds, same as oxygen, fluorine, chlorine, and bromine and iodines. Common oxidation number. Generally in the whole P tables have the different types of oxidation number. Generally we find the -1 to +7. Highest and lowest oxidation ruthenium oxide and osmium oxide. Ruthenium oxide and osmium oxides plus 8, and lowest oxidation CH4 in the CH4C minus 4. Carbon have the minus 4 oxidation state in the CH4 molecules. Next, general rules. Free elements 0, monatomic charge. Example, monatomic charge, sodium, chlorine, hydrogen, Cl minus, Be double plus, calcium. These are monatomic, have the number of charge positive or negative. These have the oxidation state of these elements or ions. Oxygen generally have the -2 and some exception have the +2. Hydrogen +1, exception in the hydride -1. Chlorine have the 100% -1. Second, compound rules. Compound rules. Sum of the oxidation number equal 0. In the any chemical reactions have the total number of oxidation number 0. Example, NaCl. 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 These are have the simplest compound. Sodium has the +1 and chlorine has the -1. Total number of oxidation is 0. Here the sum of the oxidation number 0. That is the neutral compound. Second, sum of the oxidation number equal the charge. Specific rules. These are next. Define the specific rules and have the most important. Alkali metals +1, hydrogen family, and alkaline earth metals have the +2, means that calcium, magnesium, beryllium, and halogen family have the -1, exception have the oxygen and fluorine. Nitrogen have the -3 and vary the -3 to +5. In the sulfur have the -2, in the exception have the some elements, sub compounds have the different oxidation state. Next, exception in the H2O2, Na2O2 have the oxygen +2 oxidation state. These are exception of the oxygen. These are compound called the peroxide. In those compound have the +2 oxidation state of the oxygen is peroxide. Second thing, superoxide. In the compound have the oxidation state of oxygen is -1/2. Second, hydride, sodium hydride, calcium hydride, hydrogen have the -1 oxidation state. Learn about these questions next in the slide. You have solved peroxide, H2O2, Na2O2 +2 oxidation. Superoxide -1/2 oxidation. Hydride -1. And fluorine and oxygen have the +2 in the OF2 O2 F2. Chlorine with the oxygen +1. Ammonia, nitrogen have the -3. Nitric oxide have the +5. Sulfur, H2S in the +4. And SO2, sulfur have the +4. And sulfur H2SO4 in the +6 oxidation state. These are defined the next slide, and we calculate the different types of element have the oxidation number. In this simple compound of the calculating oxidation number, the oxidation of the oxygen, fluorine, sulfur, and carbon, we calculate. We know that we learn about the first A group. Hydrogen have the +1 oxidation state. Hydrogen have the first one oxidation state. Calculating the oxygen oxidation state, suppose that oxygen is X, hydrogen have the 2 elements and oxidation state +1 equal 0 because have the no charge on the molecules. So 2 + 1 + X equal 0. 2 + 1 + 2 + X equal 0. X equal are left 2, then the X equal -2. Where X is oxygen, means that oxygen have in this compound -2 oxidation state. Okay, so next sodium fluoride. The sodium fluoride NaF, sodium has the +1 oxidation state. Chlorine calculate X plus sodium plus 1 equal 0, because the total charge of the molecules have the 0. So X equal +1, left 2 -1. Have the fluorine X equal chlorine have the -1 oxidation state in this compound. Second है calcium sulfide. Calcium have the +2 oxidation state because these are alkaline earth metal. Alkaline earth metal, you now read that the +2 oxidation state, numbers of 1 plus sulfur, calculate X equal 0, have the no charge. So X equal +2, left 2 -2. In the calcium sulfide, sulfur has the -2 oxidation state. Second things, carbon dioxide. In the carbon dioxide, oxidation state of the carbon, calculate the carbon dioxide CO2. Carbon X, suppose X oxidation state plus number of oxygen 2, oxygen have the -2, have the no charge on the molecules, equal 0. -2 multiply -4 equal 0. X equal -4 to goes to the left, +4. In the compound, carbon dioxide have the +4 oxygen state. Second example, carbon CH4. The carbon have the -4 oxidation state. You learn the back page. So calculating the X, carbon have the X, hydrogen 4 plus 1 have the no charge equal 0. So +4 plus X equal 0. X equal +4 goes to the left, -4. Means that in the compound of the CH4, carbon have the -4 oxidation state, and in the carbon dioxide have the carbon have +4 oxidation state. So next, we are calculating the higher compound or salt. In the copper sulfate, ferric chloride, calcium nitrate, and potassium chromate. The copper sulfate, calculating the sulfur, ferric chloride in the ferrous, and the calcium, the nitrogen and the chromium. So one example can be calculated, and the other for you, K2CrO4. For the potassiums are first group elements. We now learn the first topics. Alkali metals have the +1 oxidation state. So potassium have the +1 oxidation. Numbers of potassium 2 plus. Chromium, we calculate the oxidation state. Suppose the X plus number of oxygen 4 have the oxidation state equal 0. Oxidation state -2, total equal 0. 0 because have the no ionic charge on the molecules. So calculate +2 plus X -8 equal 0. Left to side, X equal +8 plus 8 -2, left to -2 equal X equal +8 -2 equal +6. Means that in the compound K2CrO4, chromium have the +6 oxidation state. Okay, so next, complex compound, calculating the oxidation number. K2Cr2O7, potassium dichromate. Calculating the first K2Cr2O7. K2Cr2O7. in this compound complex, calculate the chromium oxidation state. Suppose the chromium oxidation state is X, numbers of 2 plus potassium oxidation plus 1, number of 2 plus 7, oxidation state of oxygen minus 2, charge is 0, total charge. 2x plus 7 2 ja minus 14 plus 2 1 ja 2 plus 2 equal 0. Minus 14 to left side plus 14 plus 2 left side minus 2, 2x. X equal plus 14 minus 2 plus 12. We are calculate the x equal plus 12 upon 2. We are cancel, then the form plus 6 oxidation state. Means that in the K2Cr2O7, Cr molecule, Cr element have the plus 6 oxidation state. Next topic. Thank you for watching. I hope you learned the oxidation of the elements. Thanks.